prefer to establish a hybrid solution so that to keep the system running. So such kind of systems, once integrated for, I mean, commercial application, can provide a huge amount of financial revenue as well as can boost the economy of the country. And thank you so much.
Thank you, Dr. Sultan. Thank you for joining us.
Yeah.
House has no concern. Thank you.
Yes. Any question, please?
The question from the house. Sir, there is no question. Thank you very much for joining us and such a valuable talk. Thank you once again very much. It's been an honor.
Thank you.
Next, we have Dr. Faisal Salim with us. He is an associate professor in the Department of Chemical and Polymer Engineering at the University of Engineering and Technology, Lahore, Faisalabad campus. He earned his PhD in chemical engineering from Newcastle University, UK, focusing on biomass gasification, tar treatment using non-thermal plasmas. With over 16 years of academic and research experience, he has published more than 50 papers and secured over PKR 35 million in research funding. Dr. Salim is also a peer reviewer for several journals and a senior member of the International Association for Carbon Capture. His research continues to focus on renewable energy technologies, plasma assisted pollutant removal, and sustainable hydrogen production for net zero emission system. Welcome, Dr. Dr. Faisal, please. Thank you. Thank you very much.
Hello. Assalamu alaikum. Um, my name is Dr. Faisal Salim. So thank you for your kind introduction. I'm currently working as an associate professor at the Department of Chemical and Polymer Engineering, UG Lahore Festival campus. So I have completed my PhD in chemical engineering from Newcastle University, UK in 2019. So here currently in Madad, Pakistan, we are suffering a lot of this fog and air pollution things. So as you have read in the news, right today maybe AQI index is 300 around, and it is very critical for the human health and environment. So basically, this is the approach which we want to use in as you put that there are uh, multiple things which causing the air pollution, vehicle emissions and the burning, crop burning, deforestation and the industrial heating units, for furnace boilers and other things. So, and going challenge for Pakistan studies, Pakistan is one of the most polluted countries with several obviously consistently listed among those with the poorest problem air quality, in which you can say that Karachi, Lahore, Faisalabad, Rawalpindi are constantly in rank in those cities which are highly polluted. And second one, why we are focusing on these things, because air pollution basically it's a major concern for the human health. for especially for the elderly people and the young one, or less than 8 years old and above 65 years old. So the major causes of air pollution in Pakistan, as you all know, that vehicular emissions and industrial activities, agriculture, residue burning, and urbanization and deforestation. So here basically these are the, as we know that there are a lot of things which are contributing towards the air pollution. Here in this section we will focus only one, industrial activities. Okay, so how we can counter those things and how we can play a role to minimize the particulate emissions from the industrial activities. So industrial source of particulate matter pollutions, particulate matter include solid and liquid particles such as dust, soot, fly ash, char, and aerosols suspended in the air. If you have ever visited the industry, you can see that whenever they are charging the, for example, furnace or boiler, there are a lot of dust, and whenever they are after burning, the smoke is also coming from the and the exhaust of the furnaces and the boiler. So what happened, it is critical for the workers who are working there for health and for the overall environment, because when the weather is changed, what happens, these particulate matter contributes towards the smoke formation. So these are the things which we should focus. Industrial tools are majorly contribute due to fuel combustibility, handling and manufacturing operations. As during there are other causes except from the burning and the other things which are contributing towards the, for example, loading or offloading dust particles. But here we only focus on the furnace where we are using the fuel, solid fuel, just like wood and coal, which due to incomplete combustion, they are contributing to the particulate matter emissions. So the composition of industrial particulate matter which are coming from the combustion from the heating units of the industry, there are two types. One is inorganic, the other is carbonaceous. So the carbonaceous is inorganic sulfate, silica, metal oxide, and ash. These are basically after the complete burning the residue you can get from the bottom of the boiler. So these are the inorganic. The main focus is here carbonaceous. So soot, char, hydrocarbons, organic compounds, polyaromatic hydrocarbons, VOC. Whenever we are burning solid carbon or coal or different things, so these all coming from the exhaust of the boiler. So they contribute to the affect the local community as well overall the country environment problems. So according to Pakistan Energy Outlook Report, major fuel use in industry includes solid fuels, coal and firewood. So basically there are liquid fuels and gaseous fuels, but majority the people are using, if you visit around Faisalabad and Lahore Belt, you will see most of the people they are using basically coal and just like Star Chemicals and the other industry, even local industry are using discarded clothes, discarded pampers, whichever they are getting, discarded plastics, anything which are very harmful for the health. It is the coal and firewood is the most, you can say that the industry, they are sophisticated industry which are using coal and firewood, but they have also significant emission if they have incomplete, because due to incomplete combustion and their compositions and the combustion gas. Now, from that point to that slide, that was the overall, just the little bit introduction. What is the air pollution and what factors are contributing and how we can overcome the industrial emission control in industrial units if they are using coal and firewoods. So the first question, how we can overcome these, and second is why. Is why we integrating the electrolyzer here. So how we can answer that? We have observed that whenever we have used whenever we co-feed the hydrogen along with the air during the combustion process at high temperature, that hydrogen contributes towards the formation of C1 to C3 hydrocarbons instead of heavier hydrocarbons, VOC formation, soot formation, and all the toxic pollutants, even the most of the carbonation material completely converted to C1 to C4 hydrocarbons. So it and if you will observe the smoke, the color of the smoke, it would be colorless as compared to the dark smoke. So this is the proof of concept. How it came into our mind, we should co-feed the hydrogen into the industrial heating units. The question is that how it came into our mind. So this is the proof of concept. I remember PhD and I have supervised some of the PhD students in Kasaragod University. So there we have observed that whenever DPT is a type of reactor, whenever I have studied the gases, the synthetic product gas which are coming normally from the gasified product gas which consists of CO2, carbon monoxide, hydrogen and some compounds and some impurities. So basically we want to clean that synthetic product gas. So when we pass through the DPT reactor, that is a special diagonal thermoplasma reactor. So when we pass through that composition synthetic which are coming from the gasified, it was similar to that composition when we pass through the gasified. So we have observed that significant amount of solid residue formation occurred inside the reactor and the VOC formation completely disappeared. But rather it converted to the clean fuel, it converted to a more toxic product. So the problem was still there. So we cannot overcome that problem. So then we want to analyze how different gases contribute, because you can see that there is a spectrum of gases. There are different gases which are present in the gasified product gases. So we don't know what's happening inside. So we have studied one by one each gas and we set the model compound just toluene, benzene and xylene. When we set that and we increase the surrounding temperature, we have observed that in a hydrogen carrier gas, the solid residue completely disappeared and it converted to CH4 and 10% selectivity to C2 to C4 and C1 was more than 90%. And it was the breakthrough for the first time we have discovered that, because before that people were using the steam addition to clean that, to get rid of that solid residues and some using catalysts. We didn't use any catalyst and other thing. So our point was that whenever we are using hydrogen at elevated condition, it can hydrocrack the complex VOC and soot formation. So that was you can say that the target point. So from there we got the point. So this was the setup of the reactor where we sent the different gases which carry the toluene as a model compound. So when we sent to the reactor, what happened? It completely, the toluene removal was nearly 100%, but the solid residue formation was significantly there. So extensively studied the decomposition of top model compounds in each gasified product gas and mixture of gases under different operating conditions as we already described, and studied the effect of plasma power in parametric study, how they affect the product distribution, how they can contribute toward the different behavior, how we can get the spectrum of the different various types of products. So we have studied that. So the formation of unwanted byproducts and solid residue, ambient and ambient condition across all carrier gases. In all carrier gases, we have observed that the secondary byproducts which were more toxic as compared to original model compounds and compared to original impurity, so they were appearing. We were getting rid of toluene, but we are getting the more toxic products at the same time. Here you can see that in hydrogen carrier gas, when we increase the power, the carbon balance was only 18%, the 80% carbon was missing, even in hydrogen carrier gas and ambient conditions. And why I'm talking about, I'm going to link this thing with our recent talk where I want to connect the electrolyzer co-feeding into the industrial heating unit. And ambient conditions, when we use the hydrogen carrier gas, we have the low hydrocarbon, but only 80%, the 82% carbon was still missing. So, whereas in other nitrogen and CO2 carrier gas, more than 95% was solid residue. We are getting rid of initial toxic compound, we were getting the secondary products. So here the main point is here. So what we did, we observed that when we apply the ambient condition, when we apply the plasma, we are getting the complete removal of taurine, but we are not getting rid of solid residue formation and toxic products. But when we increase the temperature up to 400 degrees C, the surrounding temperature, the surrounding temperature 400 degrees C in hydrogen carrying gas, you can see that selectivity to low hydrocarbons reaches to roughly to 99%. In only hydrogen carrying gas, you can see the top line here. Whereas in CO, in nitrogen and CO2 carrier gas selectivity is not effective. It means that there was a punchline. In a gasified product gas, hydrogen is already present. If we can manipulate the hydrogen concentration of the hydrogen through electrolyzer, through anything, and temperature is also there. Because when the gases are coming from the gasifier, there are significant high temperature. When we are using as a feedstock for boiler, the temperature is also higher. So it means that if we can alter the concentration of hydrogen, and we know we have a high temperature, so we can control the amount of toxic products and minimize the unwanted solid residue formations. So this is basically the one of the paper which we have published in Chemical Engineering Journal in 2019. That was the pioneer work where we have studied the overall effect of hydrogen. If we observe that the right side of the top side, the first figure from 200 degrees C to 400 degrees C, there are 4 lines. You can see that at each power we have significant effect of temperature towards the selectivity to lower hydrocarbons. And here at the bottom line, you can see that the major amount of the lower hydrocarbons contains CH4, which is up to 60%. Here you can see that. At 400 degrees C and 40 watt of power, the 60% of the methane and remaining to benzene and C2 and C3 hydrocarbons. So similarly, it means that if we can vary the temperature, so we can control the amount of the desired product. So that was the individual effect. Then we have simulated CO2, CO, hydrogen. Whenever we are using the gasifier or something like that, the output product composition significantly depends on the gasified medium. So that is one of the whenever we are using a steam gasification, steam is using as a gasified medium, so roughly the concentration of this is the model concentration which we use. So this is the behavior. Here we can see that the yield of the, in this case we also observed that when we increase the temperature, initially we studied and pure carrier gas, then we use the simulated mixture of gases. So we have observed that whenever we have increased the temperature in the composition of simulated model product gas, so the CH4 yield 4 times increase. Okay, so this is the product distribution of C2 to C5. This is the nitrogen base. Whenever we are using air as a gasified medium, then the concentration of the nitrogen significantly present in the product gas. In that case, we can also see the selectivity to C2 to C5 hydrocarbons, which are affected with the temperature. So these are the physical effect of the power on the concentration CO2 and ambient temperature. So this is the point. So firstly, we discussed that what is our problem. We know that currently we are facing a severe air pollution smoke problem, and people are trying to use smoke guns, and these are not the solutions. It's just like if someone has a problem by smoking and you put the ventilator at his face and say he will be covered in 2 to 3 days. That is the ventilation. We can use as a ventilator the smoke gun, but ultimately we have to focus on the policy change and we have to apply a differential analysis instead of integral analysis. What is the differential analysis? We have to take every cause of which creating the air pollution. For example, we are focusing here only the industrial emission where we are using wood and coal and anything other material burning fuels. So we are focusing that one. So this was the problem. So basically we are trying to minimize, we can say that that's the one step towards the clean Pakistan. Because I am not saying that if we will do this, Pakistan will be clean, because vehicular emission also, deforestation, it will take some time. Secondly, so we have proposed that we are want to integrate hydrogen electrolyzer. Why do you prefer electrolyzer? Because Pakistan, you know that solar shines all over the year. Okay? All over the years we have a much of, so we can solar integrated electrolyzer, we can use that hydrogen. So basically the concept, as we know that hydrogen is a key player which can contribute to minimize the solid acidity formation, VOC formation and toxic compound formation. That was from our previous study. So this is the proposed scheme. First we got the heating unit, it could be any boiler, it could be anything in industry where people are using wood, people are using coal fire and other things. So we want to use the electrolyzer which could be solar powered electrolyzer, and we will set the hydrogen along with air and solid fuel. So what we will get? We will get clean product gas. Currently, we are trying to develop with the GS apparel. There is a local industry. They are agreed to do work in this section. So our colleagues basically they are expert in electrolyzer. We are going to install local in our industry and the boiler. So this is under process. So heating unit, what currently we have performed some experiment there, but it's not tested properly. Means we didn't analyze proper analyzer. But what we observed that the 30% of our food cost decreased because, for example, we are using if 100 kg per month, just an example. So our food cost reduced to 70 kg. The clean product gas, the smoke, the previously the smoke, white smoke and some clear. But when we installed that one, that was clear, white, clean, colorless smoke was coming from that one. But as I told you, we didn't perform the extensive analysis because that needs very sophisticated equipment. And so, the next point which we want to introduce here. The first step is the clean product gas. We can tackle the problem of the smoke, but we are not handling CO2. CO2 is the major factor which is contributing towards the climate change. So climate change, if we are talking about, so we should remove not only capturing of CO2, but also we have to utilize properly. So in the second stage, currently Durham University got 10 million funding for what? 10 million pounds funding from UK. Durham University, they are treating water, and during the treatment of water, they got the water to the water sludge, something like that, and they performing the pyrolysis of that water sludge. And after pyrolysis, they perform non-thermal plasma on that product gas and converting towards the fuel, some are converting towards the aviation fuel, chemicals and something valuable, methanol and other substances. So we want to integrate non-thermal plasma reactor at the exit at the green product gas which has significant amount of CO2. But of course you can ask there are multiple other components as well. So we will test that one as well. So we want to introduce the hydrogen from the electrolyzer to that product gas and CO2, and we want to perform non-thermal plasma, we can produce liquid fuel and chemicals. From means not only you can say that it's a two-step process. In a first step, the direct reduction of particulate matters and soot and other. In a second step, the gases clean which are coming, we convert that CO2, we want to convert that CO2 to valuable through the plasmolysis by applying the non-thermal plasma. So we can integrate the hydrogen and they get the ethanol formation or other. As you have studied the Fischer-Tropsch synthesis, but it is somehow different, a little bit from that thing. So, in short, co-feeding hydrogen generated from solar power electrolysis with biomass and coal significantly lower particulate matters, ash and toxic emissions, leading to visibility cleaner combustion and reduce smoke formation. That was the first step. The hybrid system enhanced combustion efficiency. That will, of course, as I told you, whenever we install the our consumption of the fuel will also decrease. So it will increase this Pakistan transition towards renewable and cleaner industrial heating technologies. So supports Pakistan renewable energy and climate goals, and of course, as you know, SDG 7, SDG 13 and different providing a reliable model for other developing countries. If we are successful in this one, we will patent this technology and we can send to the other developing countries with this one. So this is all from my side. Thank you. Yes.
Thank you, Dr. Saab. House have any question? This talk is regarding smoke. No question? Thank you, sir. Thank you very much. Next. Biofuel selected as role model by US Times Higher Education World's University Ranking and Fellow of Irish Research Stimulus Funds. Thank you, Dr. Abdustan Nizami, for having with us for the talk.
अंडर ग्रेजुएट ग्रेजुएट मुझे पता था वो मेरी ऑडियंस कौन है आप क्या बीएस कर रहे हैं एमफिल कर रहे हैं मास्टर के स्टूडेंट आप ठीक है दैट्स गुड चले शॉर्ट सी जर्नी है क्विकली वी विल गो थ्रू ठीक है बहुत ज़्यादा मैं कम्प्लेक्सिटीज़ को अवॉइड करूँगा ठीक है ताकि की मैसेज जो है वो आप तक पहुँच जाए दैट्स वेरी इंपॉर्टेंट ठीक है आप इसलिए आए हैं आज सारा दिन तो ये मेरी थोड़ी सी जर्नी है स्टार्टिंग फ्रॉम ए विलेज टू लाहौर एंड देन टू स्वीडन फॉर मास्टर PhD आयरलैंड पोस्ट डॉक्टरेट कनाडा देन आई वर्क इन सऊदी अरेबिया and 2019 end of I came back to Pakistan. Beside my role as an associate professor, I'm also like a distinguished and adjunct professor in various universities, Korea University in China and King Abdulaziz University in Saudi Arabia. So my concept or my area of research is basically renewable energy circular economy. I'm pretty sure all of you know the concept of linear economy. This concept based on taking, making and disposing means we extract the minerals, oil, gas, wood, metals, we make our products to perform of a life and then at the end we discard, dispose. So this is how it works. But if we twist this linear economy model, straight model into a circular way, circular fashions, what's happened actually? So we try to minimize the natural resources, we try to minimize the pollutions, we try to minimize the waste materials at each phase, like a manufacturing, production, distribution, end user, disposal. And even like if there are waste materials, we try to reuse, reduce, recycle, and make it a part of the system again and again. So this is the whole concept of circular economy. And this concept is amazing in that sense because it reduces, it intervenes directly and reduces the carbon emissions. And waste materials are become a part of the system. So basically, in linear economy, we see is a burden, economic burden, environmental burden, social burden, as you have heard about the smoke. So if we have a circular economy, nothing is wasted. So it's becoming economic opportunities, social opportunities, environmental beneficials instead of burden. So in circular economy, we always have a circular supplies. We do not rely on oil and gas, natural materials all the times. So it's like we will have a green environment. We talk about resource recovery, sharing platform, product as a service, and all these new concepts in circular economy that is very much related, linked directly, indirectly, one way or the other with the sustainability, circularity. And if we see the definition of circular economy by World Economic Forum, you can see they also say the circular economy is an industrial system that is restorative and regenerative by intention and design. So nothing is like a considered waste. So that's the way forward for developing countries, for our countries, for poor countries. So if we go in detail, the circularity points, the principles, the criteria, it's very much linked with the sustainability goals like SDGs and even Pakistani NDCs, nationally determined contributions. So obviously we talk about the circularity, we talk about reducing, reusing, recycling, refurbishing, redesign, all these concepts. And talking about sustainability, we all talk about the renewables. Instead of fossil fuels, we talk about the waste to energy, the waste to value added products. And circularity linked directly and again with so many SDGs. For example, the 12 SDGs, sustainable consumption and production. We can do among these options. And obviously all these options bring economic opportunities, environmental benefits, health benefits. So why we need circular economy in Pakistan, by the way? We are already like, as you just heard about smoke, we are already like fighting with the managing resources, distribution of the resources, equal distribution among the provinces, within the provinces, tackling pollutions, climate change, induced impacts. So all of our models is linear economy. We heavily depends on the very expensive imported oils. So obviously it's result in pollution, climate change, and so many other vulnerabilities. So that's why we need circular economy in our country. So if we have a circular economy in Pakistan, for example, so we will be able to reduce the waste, we will be able to optimize the resources, reduces carbon footprint, new jobs, new opportunities, green businesses, startup, entrepreneurship, so many other things we can have with this circular economy. So just giving you a model, just to explain you how it works. This is linear model. You can see extraction, you can see production, use, end user, like you are sitting, and the end of life. So taking you as an example, end user. So if you are using some product like a plastic bottles in front of you. So see if you can do here. Can you do some magic with it? Can you say no if you do not need it? Okay, if you use it, then you can say, can I reuse it again? can I reduce the waste volume I'm producing? Some of the things you can do, many of the things you cannot do. Obviously, you send these material back to the manufacturing industries, factories, production units, and they try to recycle it, redesign, refurbish, and make these material again part of the system. So basically, we are trying to reduce the load on the virgin material, raw material, precious raw materials, because that's expensive, that's limited. So if we cannot do anything, we dispose all of our materials, dump site, landfill sites. Again, landfill sites, you can see like a loss of waste pickers, scavengers, they do pick up the small item, recycle, send back to the manufacturer. Obviously, it's become part, or you can redesign the whole system. So this is the philosophy of circular economy. So achieving circular economy means you are also at the same time in parallel achieving zero waste concept. And that zero waste concept is linked with zero lifestyle, with our lifestyles. And that's linked how we think, how we perceive about the waste. So it's up to us. Obviously, if we see that we have listened the examples of developed countries, other countries, they change this perception. They said waste is no waste anymore. You can say it's a treasure, it's a black gold, it's something valuable. It's not something discarded, it's not something bad, it's not something refused. So there is so much potential hidden in that waste. You can see in our garbage bins, bags, whatever we throw away. You can say it's a recycled material, it's a green material, it's energy, it's chemicals, it's compost, you can name anything. So it's full with the cheap and valuable source of gases, carbon materials, energy, fuel, electricity, chemicals, fertilizers, economy, revenue, money, so many. But obviously you have to manage the waste in a sustainable way in order to get all these benefits step by step. But in our countries, as we follow the linear economy, what we do in Lahore, for example, we collect all of the waste and we ignore all these steps. We straight away go to the dump site, and that is like an open dump site again. We dump all of our treasure over there. So I had like a work with textile sector as well. So we work the circular cycle for the textile sector. Basically, this concept can be applied to any industry in Pakistan, any sector. And it will bring the beauties, it will bring the opportunities, it will reduce their bills. But there are certain limitations with a single system. If we talk about the waste to energy, waste to recycling system, waste to any value-added products, because without any subsidies, without any financial supports, currently it's not economically viable, that's true. And it's not in that position that's gonna change the whole fossil fuel economy all of a sudden quickly to renewable economy. We need to integrate all of these technologies under biorefinery concept, and that is the pathway basically, very practical pathway. And that's biorefinery concept emerged from petroleum-based refinery, and then we have a biomass, citrus waste, C2-based biorefinery, and now my research team back in 6 years before in Saudi Arabia, we introduced zero-waste biorefinery concept, and we had a huge success scientific community because these waste biorefineries are directly pathway, give a roadmap if we want to have a circular economy in any country or society. And several SDGs link can be achieved with this only one biorefinery. So basically what's happened in this biorefinery, we integrate all these different technologies together under one roof. So it's a holistic and sustainable approach. And we have all of the waste, doesn't matter, it's sorted out, it's segregated at source, and we separate the waste according to its contents, its waste nature. For example, all of the organic stuff can go to AD to produce biogas, and that biogas can be upgraded to biomethane, can produce electricity. All of the paper, cardboard can go RDF, all content can go to rendering, transesterification process. The beauty of this system is, obviously one process will produce either electricity or oil or something like a valuable. so that electricity, power, or oil or gas can fulfill the requirement, energy requirement of the other system. So it's such interconnected system. Thus, we do not need any external heat, power, electricity. So it's a self-sufficient system. Benefits of having these biorefineries, for example, in Pakistan, R&D, waste problem, big problem, is the magnitude is high, quantum is very high. Smoke is just an episode of this. Minimizing environmental pollutions, jobs, new jobs, obviously, and having all these benefits we never quantify in Pakistan, for example. The cost of the pollution in terms of the health cost. So obviously, if our skies are clear, if our waste is disposed and recycled to some valuable economic opportunities, our health will be improved. So giving you a quick case study example, we did this work in Makkah city when my team was there in Saudi Arabia. We have like a snapshot of the whole waste of Makkah because we were invited by the ministry to do something because during the Ramzan month and Hajj time, there's very high peaks of waste in Makkah. So we like calculated all these and we try to prove this concept even at lab scale to develop such biorefinery. So we will be able to solve more than 90% of the waste at one roof and one factory. Obviously the number of like a million Saudi Riyal, but obviously converting them into Pak rupees also like a billions of Pak rupees. You can see like if everything is millions saving, oil barrels, million cubic feet of gas will be saved, global warming potential will be achieved. How many like these jobs will be provided? Recycle products, resale of the recycled products. Now coming back to Pakistan, energy demands is very high, shortage, electricity. Obviously our energy mix is not sustainable, is always changing, keep changing with our policies and our importers of energy. So we need to have a more like a sustainable approach. The good thing we have this energy security action plan make in 2005 and we have a vision 2030 accordingly. And that's like it tells some direction that we have to switch fossil fuel to renewables, we have to build wind, solar, depending biogas, depending on the resources available in different provinces. And we also like a part of like a Paris agreement we signed, we also like approved in our parliament SDGs agenda, we have NDCs, we have so many other contribution and target to achieve, and that is like approved by our parliament. So that means that's also like our own Pakistani agenda. So many, I can say like most of the agendas, most of the targets can achieve with the circular economy. But the challenge at the moment, while transitioning from linear to circular economy, we have a limited awareness, knowledge at the moment, capacity building another hurdle, existing infrastructure obviously. So if we have this, so we need to prioritize the development of sustainable infrastructure, for recycling facilities, waste management plans, renewable energy initiatives. We need to have a substantial investment in infrastructure. These are few of my works. This report I wrote for UNEP, West Asia Waste to Wealth, is publicly available. You can download. I also part of the Punjab Climate Action Policy. I made action plan on the solid waste. This is the first time report in Pakistan, financed by World Bank, done by EPD. There was 2 years, 2022, 2023, Punjab State of Environmental Report. First time ever in Pakistan, the real data was like analyzed, captured, and they presented in these two reports. In these two reports, I covered like 9 districts of the Punjab, did the sampling of the landfill side, air emissions, incineration, their stack emission, fly ash. This is the first resource in Pakistan. I was part of this. And I also like this master development plan for Lahore. I also like make a plan for solid waste for the Lahore till 2050. So thank you so much. This is from my side. If you have any question, please feel free to ask.
Our final invited speaker is Dr. Nadeem Sarwar. Dr. Nadeem Sarwar is a distinguished researcher and academic academician specialized in artificial intelligence, machine learning, IoT, and energy efficient computing. He has authored over 70 research papers in reputed journals, including IEEE Access, Sensors, Computers, Materials, and Concua. He has received multiple international and national awards. As an IEEE senior member, Dr. Sarwar serves as commission editor for the International Journal of Telemedicine and Application and holds editorial position in leading journals such as Security and Communication Networks, IIT Software, and Journal of Healthcare Engineering. He is also reviewer of prominent journals by IEEE, elsewhere, and other reputed journals. Welcome, Dr. Nadeem Sarwar. Thank you for joining us.
Assalamu alaikum, dear audience. Okay. Assalamu alaikum, dear audience. My name is Dr. Nadeem Sarwar and I'm from Bahria University Lahore campus. Today my topic is sustainable AI, intelligent computation with the purpose, precision and efficiency. So I'm focusing on the topic AI is transforming the industries, yet its growing computational demands raise serious concerns about energy consumption and sustainability. So, sustainable AI focusing on designing algorithms and computational infrastructure that minimize the energy use, optimize resources, and ensure that every bit of the computation serves a meaningful purpose. So, from cloud to edge computing architectures to refined prompt engineering in large language models, efficiency is becoming a key metric, not just in performance but in the environmental responsibility. So as per the Sustainability Development Goals, we are focusing on SDGI 3, 9, 12 and 13. So this diagram shows that the energy efficiency play a vital role in many fields like edge, cloud, GPU, CPU, TPU, clock gathering and DevOps and trade sustainability. So there are many areas where the energy efficiency required. So the era of the intelligence, but at what cost? We are using many resources, but we have not focused how we can use low power devices. Like the AI and the digital transformation are reshaping every sector, yet growing AI workloads consume massive energy resources. Like training a large AI model can emit as much carbon as 5 cars in their lifetime. So, challenges we are facing, how do we make intelligence sustainable? This is the key point of this presentation. So, what is the sustainable AI? Designing and deploying AI systems that are energy efficient, ethical and responsible, balances performance with planetary well-being, integrate principles of green computing and energy optimization into AI design. So our objective is the smarter computation with minimal ecological footprints. So green computing, the backbone of the sustainable AI. So energy efficiency, sustainable design, virtualization and cloud efficiency, e-waste reproduction. These are the focus areas related to the sustainable AI where we can use the resources. So green computing concept is that we have the environmental practice, sustainable practices where transformation technology emphasizes the energy, waste reproduction and eco-friendly. So this figure shows that the role of green computing using sustainable AI concept. So computational intelligence meets also the sustainability. How? The AI models can optimize their own energy use. So example is the adaptive learning algorithms that regulate GPU utilization. Nowadays, many students writing a programs and making a software, but they are not focusing how they can use resources. We can also control energy resources via our programming techniques. So here is some examples I have mentioned in my slide. We need to focus on every part of the integration. We need to focus on every part of the integration. So this infrastructure, we are using many nodes. They are connecting and transferring of data from one place to another place or one node to another node. There are a lot of integrations required, but we are not focusing on the low energy devices. So efficient algorithms and model design are important because model comparisons like quantization, pruning, also reducing energy cost. and federated learning technique also reducing our energy cost, and auto machine learning and neural architecture searching for optimal resource utilization. We can also use such type of algorithms to reduce energy cost. So trade-off between the accuracy, interpretability, and efficiency. So these are the focusing areas for upcoming researchers. So this is also a trending topic, refined prompt engineering. We are daily basis we are using on many generative AI models like ChatGPT, Gemini, and DeepSeek, etc. So, but we are not focusing on the query prompt, how we can write a good query or prompt engineering where we can save energy resources. So large language learning models depends on the high computing prompt drive cost. Efficient prompt is provide us the efficient computation. When we focus on efficient prompting, then we can achieve efficient computation. So use structured, context-rich and minimal prompts to save interference time. Meaningful prompts lead to lower compute waste and higher accuracy. When the long prompt flow, we can use long response time. When we use optimized prompt flow, we can achieve a faster output. So this diagram shows that the comparison between single task and multitask prompt engineering. When we use this multitask prompt engineering, we can directly achieve our output. But when we follow a single task, then our query decompose in multiple tokens. So these are the practices for programmers who can adopt such kind of practices for focusing on energy optimization and energy conscious designs. So first example is the energy aware model training. So we can use these functions to train our model, which model is energy aware training model. So stop training when performance plateaus, save GPU time and reduce power consumptions. So this type of functions reduce our model training computational cost. So second example is the model containerization for edge devices. So in this example, we can use containerized models. These models will help us to reduce energy cost. How? Compresses model weights to use lower precisions, enable AI inference on lower power IoT and edge devices, and also reduce energy use, extends So I hope all students know the difference between runtime and compute time. So sustainable data centers, integration of AI powered cooling and renewable energy resources, and AI for climate research. That was already professor talk about the climate, the leveraging machine learning for environmental prediction and energy optimization. And the last one, the ethical AI governance. There is the last one, the policies for carbon reporting, energy auditing, and responsible AI life cycles. So these are the future directions for the new researchers. They can use these terminologies to find out more knowledge. So the purpose, precision, efficiency. Towards responsible and regenerative intelligence, the next generations of intelligence will not just artificial, it will be aware. So we are focusing on sustainable AI is not a limitation, it's the direction for innovation. So together we can design systems that learn smarter and faster and consume less energy. So the final message from me, the sustainable AI will provide us the smarter, greener, and the purpose-driven computation. So innovation must coexist with responsibility. Each algorithm, prompt, and model choice can contribute to a learner digital future. So here is my email ID. If anyone want to contact me, I will reply. Any questions?
Any question from the house? Thank you, sir. Thank you, sir. Now, we are moving towards ending this valuable session. Once again, thank you all the invited speakers and the participants. All the talks are valuable contribution in the field of energy conservation and efficiency. I would like to thank Mr. Atif Munir for managing this wonderful session. Thank you very much.
and gentlemen, as we conclude this successful ICE 2025 conference, let's take a moment to reflect on our achievements. We received 47 paper submissions with 16 papers accepted with 34% acceptance rate. Our technical program committee, representing 11 countries and supported by 52 international and 14 national reviewers, ensured the highest academic quality. The conference also features 6 national and 5 international invited talks, bringing together diverse perspectives and inspiring discussions. Before we move to the closing, let's take a quick look back at today's highlights through this short video.